Lee. I'm the color products manager, but also for Kodak. But I also moonlight doing my standards jet setter act. I fly around the world. I'm the co-chair of the ICC, moderator for JWG7 color management for ISO TC 130, color chair something guy that gets sat on in Ghent work group. I basically seem to have been going around talking about color and evincing some vague sense of passion about color for the last several years. And then, so I thought what I'd come to do for this conference was to come talk a little bit about an industry issue to do with color, and then produce a proposal for a fairly modest solution within PDF, and maybe perhaps even recruit a few people that are out there that are building various PDF tools, RIPs, and so on, into buying into this concept. And then I had a conversation yesterday, and I realized that I probably should put just a wee tad more effort in this particular talk, talking about color, and maybe a little bit less about the PDF, because the question had more to do with, so how do you go about characterizing color again? How do you specify color? So maybe we should just start right about there. First off, ECG, extended color gamut printing, which was reproduced in the talk description, but of course doesn't actually tell you anything about what it is that I'm going to talk about. So hopefully I'll talk about what I'm going to talk about throughout this talk. Color is about a little bit more than just making pretty pictures. And this is probably like one of the traditional things that you would see or think about for those of you that have thought about labels like ECG, extended color gamut, hexachrome, other labels that floated around the industry. And I'll be quite frank, I'm talking in this talk much more about the production end of things, and much less about other issues that are important, like accessibility, for example. But color is actually a bit of a big deal. Looking in the past at some of the stats you can flow around, just to chuck out some numbers, because it's always a good idea in these talks to throw out numbers just to make yourself sound important. Back in 2010, if you were to add up the total loss to the US industry alone due to returns of merchandise due to the wrong color, what do you think that number would be? In terms of dollars. Millions? I heard millions. Billions. 1 billion, actually, $1 billion. If you go worldwide, a few years later, another stat from about 2015, I think, was when I saw the study. Worldwide, that number was in the billions. That was more like $30 billion due to wrong color. Color matters. You think about your experience going into a grocery store. If you see a line of cereal boxes, they're all supposed to be Fruit Loops, well, not Two Loops, but Fruit Loops, and one of them's a different color than the rest. You're not going to buy that one. So color actually kind of sort of matters. It matters in part to make things stick out, in order to attract the dollars that pay for the rest of that pipeline. Red's an interesting one. I mean, red, if I say red, what's the separation color name that's most likely to come to mind? Think about things like Coke Red. I was actually going to go and borrow the Coke cans from the gentleman sitting at the front here, but they walked away and took their Coke cans with them, so I can't do that anymore for this talk. But if you want to be a printer and you want to produce printing for Coke, whether it's signage or making cans, you need to hit all those brand colors, those important colors, to within the tolerance of under 2 delta E. Color matters to the people that are paying the money for getting these PDFs processed and actually turning into ink on paper or plastic or metal. Now, in the PDF world, something like Coke Red, that's what we would think of as like a separation color, a spot color, because traditionally people have associated a spot color production with something that is like the ultimate in stability. But it turns out that's actually not so. Like for one thing, if you think about the way separation color is defined in PDF. At best, what have you got? Show of hands. PDF geeks in the audience here? PDF geeks in the audience? Okay, half of you. Okay, good. Yeah, right. So, no need to apologize for being PDF geeks. That's actually the audience I originally thought I was going to speak to here. So, forgive me for indulging in some minor geekery. So, inside a separation color space definition, at best you've got like an ACS. At best you can pick out something that's translatable to the real world, assuming that you actually intending to print with the Coke Red. At best you might have, traditionally you might have something like an LAB specification for the way the spot color is. Now in PDF 2.0, of course, you can toss in other metadata at the end. That's all that CXFX4 stuff to further nail it down. But in terms of the model for how you actually go and specify and verify whether or not you got what you got, in some sense, that's a little bit of a loose standard, either too loose or too tight of a standard, depending on where you want to go with that. In real life, if you want to actually hew, no pun intended, H-E-W, to that specification for actually producing in color, that may not always be the most, well, I was about to use the word right, but right's not even the right word. The proper word is actually the most economic thing to do. So that brings me back to the conversation I had yesterday with a gentleman in the back of the room. And he asked me here, how do you specify color? And I said, well, no, there are three main ways to do it. You can talk about color in terms of like the name, like I work for Kodak, so Kodak yellow is Pantone 123. There's a color name, right? Which presumably rests on some ecosystem of ways to specify and actually produce that color. There's the LAB specification for the color, which colorimetry, that colorimetry only works under certain lighting conditions. And if you take a color that was produced to hit a certain LAB and you move it to like Walmart or some other place, maybe not, you get like the color that you expect, especially when you do things like trying to make sure that the can of Coke matches the carton that you're putting, which is also supposed to be Coca-Cola Red that you're putting the can into. And then there's the spectral color, like CXFX4 from PDF 2.0, and that's in some ways a little bit too restrictive. I mean, imagine trying to use a CXFX4 spectral reflectance specification as the way to print Coca-Cola Red on a newspaper ad. You can do that, you can use that specification. However, what happens, like there's no way you can print Coca-Cola Red on newsprint. You just can't hit there. I mean, if you hand that to somebody printing a newspaper and you say, I want this in ad, they'll say, sure, I am going to take the singular ink, because spectral reflectance is a really tight specification in a lot of ways. And I'm going to take that Coca-Cola Red ink and I'm going to print it on the super bright white paper, and then I'm going to glue it onto every single newspaper. So your 25-cent newspaper is going to cost you like $10 a copy. You want to pay for that. Economics always plays into this sort of thing. So because economics is actually really a factor in how you produce color, That's why people started in the last 10-ish years, it's become much more popular as a way of producing things. Instead of using spot color inks to produce the color, using an extended process set that you fix all the time. Now, digital printer manufacturers have known for a long time that this is the way things work, because you are not going to change the toner in your digital printer just on a whim. Well, unless you're HP Indigo, which that's another case. But then if you want that special ink mixed up on your Indigo, you're going to pay, or if you're on your Nexpress or on some other device where you can do that. Most of the time, you get whatever colorants the digital printer vendor has supplied to you, and that's it. And whatever that process set is, you figure out a way, you meaning like the CMM/RIP/BFE, whatever label you want to attach to that, do the math to figure out how to get that color. And that's essentially the what ECG is about. You guys can all see the black egg in the background, right? There's really seven eggs in here. So ECG is about printing with more than 4 colors as part of the process. And that's why this, I've got this letter N sprinkled throughout the first few slides here, because in the PDF context, that is equivalent to, rather than using device CMYK or to go up to a subtractive process or device RGB to go out to your monitor, using like device N in some hand-wavy, iffy, wobbly, hand-wavy type of sense, rather than using separation color spaces. Okay, so that's all the preamble I'm going to do for the time being. It's the idea of using overprints to create other colors. But so you can start with CMYK. So people do this because if you have CMYK, you can get a certain number of colors. You get this sort of a fakery projection view, which doesn't really tell the story, but forgive me, allow me to wave my hands, and you get to use these types of diagrams just as a means for me to say that, if you want a certain color, then you want to make sure that you're going to use the right set of primaries in order to build up your extended process set. Okay, that's great. So this is all about why you use ECG and how you choose colors. You guys are all experts at now, and at the process of how you use it. RGB image, right? RGB image, put it through, name your ICC profile here, you get 7 color separations, great, you print it out. Well, it's not so great in a PDF workflow, because in order to do all this, even this, that image up there ostensibly ought to have been, I ought to have been able to take my 7 color image that I ran through an RGB to 7 transform and just did a copy and paste into PowerPoint and then poured out my PDF. Doesn't work. I can't put a 7 color image in Illustrator or InDesign or Quark Express because, well, it's not really the fault of the vendors that make the software. There's just no way to do it. There's just no reasonable way to do it. And there's a bunch of things that conspire to make that a thing that you can't really do, right? And I'll talk about them shortly, like here. The conventional PDF view, where PDF came from, is that only appearance matters, right? That's why there was the evolution of things like PDFX that talk about not only where you come from, but where you go to, right? From to, I don't know the sense of this facing the audience here. So if you want to be able to, if you want to think about things like producing with N colors, with 7 color process, for example, a number of things as a result don't work. Right? Transparency model, well, I shouldn't say doesn't work, it's limited. Right? So Today, you can do some things that you'd like to be able, you can do some things with transparency if you have 7 colors, 5 colors, 6 colors, separations in your PDF, but most things just, well, they just don't work. Users, in order for it to be attractive to people that make tools that work with PDF, that author PDF, that do PDF, you want to make it so that there's consistent behavior for these in-colors objects, just like you would have in today's PDF model for gray, RGB, and CMYK. Right? So that's one of the blockers. So there's 3 areas that are key here. The biggest one is transparency, and talking in the past about why dealing with in-color is a challenge in PDF. Why people have said, oh no, it's too complex. I remember some of the early discussions we had about this, and the reaction I got almost universally was, this is too complex. Don't even think about it. Because there are a large number of rules within PDF for how to calculate the result of your transparency lens stack. I mean, today, all you have is that if you've got a lens stack N on top of M, if I can be so bold as to misstate things, that transparency stack only works in separable blend mode, meaning if you've got like, red, orange, violet, purple, you can only do blending on if you've got those channels below or above. And if you've got something else, then it just doesn't work at all. You only blend on the common color components. There's no ICC-based N. Now this probably only, on the surface, might only seem like it's a big deal to, well, like a color geek like myself. I mean, why would you want this? But the thing is, if you've got a device N set, then if you want to figure out how to actually render that in the correct color, let alone produce it and verify whether or not you got the right color when you go and actually make things in the physical world, there's no obvious way to do that. Yeah, you can go through the ACS, and then from there go through yet another transform to figure out what the color of the result of going through that calculation is or should be. But that's the end result of that 2-step processing isn't really the actual color that you would get if you took those 7 colors and actually hooked that out onto a physical device. ICC-based, if we had an ICC-based N, which we don't today, that would actually solve pretty much all of those problems for a large number of these cases. Because many, in contrast to 10 years ago, many vendors now are to be found that are able to make 5, 6, 7, 8 color ICC profiles. And so it's much more common to be able to do this type of thing. If we had this, we'd be able to do color handling in the same way again, like gray, RGB, CMYK. Third thing is that in the language, it says that if you are doing your blending, you should be using your output intent color space, if it's there, to use as your exchange space. But of course, if you have no ICC-based N, you can't do it. So again, that's a key lack. But it seems that, as you can tell by my leading discussion here, it seems to come back to ICC-based N. And that's really the meat of the proposal that I'm going to flash quite quickly through here. So by having an ICC-based N, you can read through this in the slides later on. By having the ICC-based N, it gives you a way to do conversion to and from N color so that you can have an appropriate blend color space. In principle, you could do this for device N, but I say, don't go there. Don't go there. Only go there if you have an actual ICC profile, because that gives you all of the specification you need to do the math you need to get in and out of color space, which lets you do both separable as well as non-separable blend modes. And not just some of them, but all of them. So it turns out that if you use the existing rules that are there today, but with the one modification where you say, don't forbid the use of N-color ICC profiles and allow for me to use an N-color ICC profile, then it turns out all the blend modes work. And this is one of the experiments I did and showed. We've been working in an ad hoc group originally with TC171, now unceremoniously booted over to TC130.
I thought it was ceremonious.
Ceremonies. Decorously, thank you very much. Lets me attend your meetings. I showed this demo where I took classic images other than the variant duck, and showed what would be a result of doing blend stacks with all the modes, but allowing for N colors. Now, first off, this is classic, RGB over top of RGB, and this is identical to the result you would get if you took these images and put it into something like Illustrator. Second, same thing, but again, CMYK to CMYK. And this is actually the thing that we want to compare ourselves against, because this is subtractive color space over top of subtractive color space. And this is what I took as the gold standard, if you will, for the reference versus which an N over N stack ought to look like. And sure enough, if I do this, and the MATLAB code I'll be making available to the ad hoc group that's working on this. So in action, I can review that. All it does is exactly the same calculations as for the regular blend modes, but again, like I said, in order to get into and out of PCS, out of colorimetric space, uses an N-color ICC profile. You can see it just looks kind of the same. Okay. And that's what we want. So all that's set up, big bunch of talk about why we should do this, and what I think is a fairly simple, modest proposal, that doesn't involve us eating babies a la Jonathan Swift. And the result is something that I think is a fairly useful addition to the PDF model. So that's it. Still a few more details to be ironed out in the mostly the back end of the 32,000-2. But no, as far as this is concerned, right? So it's not going to end up in 32,000-2. You're just shaking his head and wagging his finger at me. It's another process for it. What's next is we are looking for people to implement this or to participate in the work, to move this forward, to actually implement this in a number of products. I think this should be simple enough from what we've seen in our own experiments. It should be simple enough to just drop in with a relatively minor amount of fuss into existing code bases, and it ought to just work. And then we can start rippling it out to other applications once the back end, once other tools have implemented this. And then we can start doing things like tagging images with N-color ICC profiles. Short, simple, and thank you very much for your kind attention. If you have any questions, I don't know how many minutes I have left. This clock is a little slow here.
Is that on properly on your shirt?
Well, I was gonna make if I was going to be in the other track presentation room, I was going to make a comment, some snarky comment about, color obviously doesn't matter to most people because we couldn't even be bothered to keep the two screens the same color. But I can't make that joke here. Sorry.
Not if you use PowerPoint, it's not.
It's all PDF. Okay.
So I enjoyed this. So in JavaScript, several years ago, I noticed that the lack of ITC and color management for device and color spaces, and I actually added the ability in JavaScript where you can, you do have an color ITC profile associated with a device and color space within a PDF document. When you render that document, you can actually command line JavaScript specify, hey, that I've got this device and ICC profile, and inside that ICC profile is the name, a special tag that has the color names and the order that it expects them to be in. And it actually, any device and color space it encounters in the PDF document looks at the color names and it does a comparison, and if they're out of order, it'll just go ahead and reorder the color and values, and we'll use that for doing color management workflow on the device and color space instead of using the alternate color space. The thing I'm missing though, I haven't thought of too much, is the transparency stuff. Because I mean, we still just do, like you said, color it. So some of the blend mode, we aren't.
But it turns out it actually all just works. It's kind of magical.
It wouldn't be that hard to add that JavaScript actually.
So we should probably talk afterwards, because that's one of the rules we want. So where this work is going to end up is on a track for ISO TS technical specification, and we want to have at least 2. So we should probably chat.
Sure.
All right. I think who's next? Who's moderating the session? That disappeared. But okay, I'm quite happy. Thank you very much.